All right, for concept G, we're going to be focusing on two of the types of reactions that you saw in our previous concept. We're going to be focusing on how to write synthesis reactions and decomposition reactions. So in general, writing equations, we want to make sure we write all the formulas first. We need to make sure we balance out each of the formula's charges correctly. We need to include phases, and then at the end, we have to balance our equation. For the phases, all the elements on their own should be memorized, so you should already know from our periodic table unit our two liquids and our gases at STP and the rest being solid. For synthesis and decomposition reactions, most of our ionic substances are going to be solids and most of our molecular substances are going to be gases. And then water can either be a gas or a liquid depending on the reaction. Some other things that you need to know are the symbol meanings of how we use our arrow that separates our reactions and our products. A simple arrow just means yields or produces. With a delta over the arrow means that heat has been added to the reaction. H2O being over the arrow means that water was added. And then sometimes we'll use a catalyst, which we'll talk about later this year, that we place over the arrow as well. This formula can change depending on the catalyst. Alright, synthesis is usually two or more elements that are forming a compound, or we could have two or more compounds that are forming a more complex compound as well. So write an equation for the synthesis of copper 2 sulfate. So in this case, I'm going to start with copper 2 sulfate. So I'm going to balance out my charges, knowing that copper has a +2 charge from the Roman numeral and that sulfate is a -2. This is an ionic formula made up of a metal and a polyatomic ion, so that's why we're going to assign it as a solid. Then we're going to go ahead and break it up into its three different elements: copper, sulfur, and oxygen. So copper is a solid at STP as well as sulfur. And then oxygen is a gas and also diatomic, which we learned about in the periodic table unit, so you need to show it as O2 and as a gas. And then again, we have to make sure at the very end we balance it, so we're going to place a 2 in front of the O2. Alright, moving on to our other example, we're going to be writing an equation for the reaction of aluminum and oxygen in the presence of heat. Now for this one, I actually started writing out aluminum oxide as my products. You could go ahead and first write down the aluminum and oxygen as well. So either direction is fine for this. So here's my aluminum oxide. Again, I had to make sure I balance out my charges. Each aluminum is +3, oxygen is -2. So that's why I had to cross my charges so that I have Al2O3. Okay, this is a solid at STP, because again, we're in general ionic formulas, we're going to be assigning a solid state. So I'm going to break it up into aluminum. And then with my arrow, because it talked about the presence of heat, I have the delta over it. And then I have aluminum, which is a solid at STP, and oxygen, which is diatomic and a gas. I would first go ahead and balance my oxygens, get them each to 6 on the reactant and product side, so placing a 3 in front of O2 and a 2 in front of the aluminum oxide, and then finally balancing out aluminum. So this shows you the reaction of aluminum and oxygen in the presence of heat to synthesize aluminum oxide. Alright, decomposition, as we talked about before, is basically the opposite. We're now taking a compound and breaking it into one or more elements. We could also be taking a compound and breaking it into more simplistic compounds as well. So here we have sodium chloride that's going to get broken down through electrolysis, which is in this case going to be the use of electricity to do so. So sodium chloride balance out my charges. It's an ionic formula, so we're going to assign it a solid phase. Over the arrow, we're actually going to show that electricity was used in order for this decomposition to happen. It's going to break up into sodium, which is a solid at STP, and chlorine, which is diatomic and also a gas at STP. And then finally, I would go ahead and balance it out by putting a 2 in front of the sodium chloride and a 2 in front of sodium. And that's it for that one. So the last one here, here we have calcium carbonate that's decomposing in the presence of heat to form calcium oxide and carbon dioxide. So I'm going to start with calcium carbonate. CaCO3, I balance out the charges. This is an ionic formula, so I'm going to be assigning a solid phase to it. I'm going to draw my arrow directly after it to show that it's decomposing, placing the delta over it to show that heat was added, and then I'm going to go ahead and write my formula for calcium oxide, +2, -2, so they balance out 1 to 1. It's an ionic formula, so I'm assigning it a solid phase. Carbon dioxide, here we have our prefix method, so I have 1 carbon, 2 oxygens, and this is a molecular formula, all nonmetals, so I can assign a gas state to this. And this actually balances out as you have it on your screen, so no need to use any additional coefficients. Alright, well that's it. So we're going to be practicing more tomorrow about how to actually write synthesis and decomposition reactions further, but definitely make sure you review this if you had any trouble with any of the parts.